In this video, we will look at variables, literals, and constants in Java. Let us start with variables. I will use this cabinet to try and explain how variables work. Variables are used to store information to be referenced and manipulated in a computer program. They also provide a way of labeling data with a descriptive name, so our programs can be understood more clearly by the reader and ourselves. It's helpful to think of variables as containers that hold information. Their sole purpose is to label and to store data in memory. This data can then be used throughout your program. So if we look at this cabinet, the cabinet has different drawers that we could say in programming terms are variables in the cabinet. Every drawer has a label on it. We can see labels for food storage and ovenware. Let's just take those two. The drawer for food storage has the label or name food storage. What type of items do you think will be stored in that drawer? Yes, obviously food items. If that drawer was a variable, the type of the variable would be food, and the name for the variable would be food storage. The same is true for ovenware or linens. Now, would you store food items in the ovenware drawer or cutlery in the food storage drawer? Definitely not. The same is true for Java variables. You store only the type of items that it is defined for. Now let us look at the different types of primitive data that we can get in Java. In this table, you can see the data type, the size, and the range of the specific data type. Byte, short, int, and long are all integer data types of different sizes. Note that a long data type can store 8 bytes and an int data type can store 4 bytes. Float and double are floating point numbers or real numbers and can store 4 bytes and 8 bytes respectively. Some other data types that we will work with include booleans. So the boolean data type has only 2 possible values, either true or false. Use this data type for simple flags that track true or false conditions, and this data type represents 1 bit of information, but its size isn't something that's precisely defined. We can also use the char or the character data type that can only store 1 single character and uses 2 bytes to store. One other data type that we will use is the string class as data type. The string type will be used for text. String is actually a class, but for now, see the string data type in the same light as the other primitive data types. We will get to classes and objects at a later video. Enough talking, let us see how we can use variables in coding. Right, when you open up IntelliJ, we can go and create a new project now to test out the variables. So we're going to go to Java again there, just choose Java at the top with your project SDK selected. We're going to go to next and next again, and then type in the project name. So for the project name, I'm going to say variables, literals, and constants. Okay, and then I'm going to say finish there, and that creates my project for me. Okay, then after the project has been created, we're going to go into the source folder again, right click, say new package, and I'm just going to call this package com.example. You can name it whatever you want, and then on that package you right click and you say new Java class. This class I'm going to call now variables, literals, and constants. Now you can see there that in this one there, your project name, I've said variables, comma, space, literals, and constants, and everything, there's spaces and so forth. But when you create a new class, there cannot be any spaces. So you can create a new space by basically just using the underscore there, if you want to separate the words a bit. And then I'm going to say OK there, so that's the name of my new class. And then because we need to have this class run our application, then we need the main method. So we're going to say public static void main, that's the shortcut, and then there's our main method where everything should start. Now in the main method, I'm going to create 2 variables. So I'm going to create a variable called first number, and I'm going to create a variable called second number. Now in Java then, when we declare variables, the int part there, the very first part there, is called the type, and in this case it's an int or an integer. And then the second part there of the declaration would be the name or the label for your variable. Now the name for this variable is then first number. So let's look at the second one. There's the declaration. That's the type. It's going to be integer. And then the name or the label for that variable will be second number. Now just note again that there's a semicolon after every statement. If you leave out that semicolon, it's going to give you a problem there. It will say that it is expected. So let's assign some values to these two variables. So let's say first number. Now this is the assignment operators, the normal equal sign there, and we're going to set a value of 11. Well, you can set any number there. So the first number then I'm setting as 11. Now because this first number was declared as an integer, I can only save integer values into it. That's like the drawer again. The drawer's type is now integer. The label on the drawer will be first number, and what am I placing inside of the drawer will be that 11. Now if I make the 11, let's say 11.5, which is now a floating point number or a real number, then if you hover over it, you can see the error there. It found a double, which is a real value, and it requires an integer. So we can only save integers into this variable called first number. Let's go back. We can also not save any text. So you can also see there it picks up this is a string. Now remember, string in Java is basically text, and it's required an integer, but it found a string. So you can see again that it's only integer values that is allowed there. So let's just leave it at 11, and I'm going to add the second number. Let's assign the second number a value of 20. Now let's say we want to work out the average between these two values. If I set 10 there, then the average would be 20 plus 10, which will give you 30, divided by 2 equals 15. But if I make that an 11, it's 20 plus 11, which will be 31, divided by 2, which is not 15, but 15.5, which is a real number. It's a floating point value, which means that if we declare a variable to hold that answer, let's call it average, we must declare that variable then as a double, so it can hold comma values or floating point values or real numbers. So that's why we declare it as a double. And then we can work out what should we store now in this variable called average. So how do we work out the average? We need to take the 11 plus the 20 and divide it by 2. So the 11 is in the variable called first number. We're going to add the second number, and then we're going to divide by 2. But now the same as your calculator would do, it will basically take second number divided by 2 first, and then add that answer to the first number because of operator precedence. So it's exactly the same thing, but what we want to do here is to first get the answer of those two values, first number and second number. That's the plus sign there. We add the 11 and the 10, and then that answer of 31 we divide by 2. Okay, so just remember that if you put brackets, you're forcing that part to take place first. Right, and then we can print out this by just typing a normal system.out.println, and what we want to print out here is the average. Now I can type this, let's print out the average like that. And now if I run this, you will see that it is the word average that gets printed out because my name average or the word average there is in double quotation marks. So if I print out to the screen and it's in double quotation marks, it will print it exactly as I typed. So in order for me to print out only the variable or what is saved in the variable, there must be no double quotation marks. So now I'm printing out whatever is saved inside of the average variable, and if I run it now, you'll see it will be a number and not the word average. So you'll see we get a 15.0 there. Now 15.0 is not correct. We'll get back to that now. Okay, so before we carry on, I want to add the word average there with a colon and a space. So I can use the plus sign again to add some text with whatever is saved in the variable. So you can see there's the plus sign again. So the plus sign here and there are two different things. Here the plus sign is actually the addition operator where we add two numbers. So it will be 11 plus 20, which will give me 31. Whereas this plus sign there is adding some text to a number, or adding a number to some text, which means that this plus sign there is not an addition operator, but it is the concatenation operator, which means to the text, I'm going to add some more text, but this text will come from the variable called average, which is a double. Okay, so we're going to print out, let's see this one now. So it's going to print out the word average just as it is with the colon and the space, and then whatever is saved into average. So you can see there's the printout. Average with the colon and the space, and then the value that we found in average. So now the value for the average is 15.0. So let's look at the average again. 11 plus 20 gives me 31. 31 divided by 2 is not 15, it's 15.5. So what Java did now is it threw away the decimal value. We call that integer division in Java. So basically what happens, your division operator, if both sides of your division operator is an integer, then Java will throw away the decimal part. So in order to correct this, I can just go and put a .0 after the 2, which will make this one a double and this part there an integer. So I don't have integer division anymore. One side is a double, the other one is an integer. So if we run this again, you'll see that your error will be corrected and we'll get the 15.5. Another way of doing this, remember you only need to change one of the two sides. I can also change this side, but I cannot go and say .0 there because we're working with variables here. So you can also cast this or convert it to a double, which means that the sum of first number and second number will then be converted to a double and then divided by an integer, which will also work 100%. So if you run that, you will get exactly the same output. Okay. So the easiest way is just to go and put a .0 there. Now let's look at some other variables that we can use. So this is basically the numbers. The ones we use most is integers and doubles, but remember there's different types of integers like the byte and the short and the long as well. And also with the double you can also use float instead of double. But these are the most used ones. Okay, so let's look at strings quickly. So I'm just going to work with a name and let's say a surname. So we've got two values there, or two variables. Both are declared as string, which means we're going to save only text as double quotation marks into these variables. Now, just a thing to note there, you can see that your int and your double are in blue there, which means they are primitive data types, and that's why it shows in blue. You'll also see when we do the character and the boolean now after this, it will also show blue. They are normal primitive data types. Because string is actually a class, it will not be in blue, but we'll get to classes later on. So for now, your variables of type string works exactly the same as with your double or your integer. Okay, so now we've declared the name as type string text, and the name of the variable or the label for the variable will be name. The same for the bottom one, the type is string, the label or the name is surname. Now let us assign some values to these two variables. So I'm going to say the name for this guy will be John, and the surname will be, let's say, Rambo. So now what have we done? We've declared the name variable as a string, and we've assigned a value to the name variable as John. Now just look at the assignment there. You can see that it is a double quotation mark and then whatever the text that you want to display or want to show or save into the variable. So in this case, it must be double quotation marks. If I try to add a number there, you can see that it says it has found an integer there, but it should be a string. It's required to be a string. We could also put a 10.8 there or 10.0. It will still be a number value. It will be a double in this case. And I can also put in characters there. So even a character, you can see it found a char there, which is a character, and it's not a string. It's not normal text. Okay, so it must be double quotation marks. And let me just change this back to John Rambo. Okay, and then when we print it out, I'm going to print out, let me just say name there, then the concatenation operator. Now what I want to concatenate is a space. So this is how I'll do a space, just a normal double quotation mark with a space in between, and then concatenate the surname. And then if we print this out, or we run this now, just after your average, we will have the name, which is John, then a space, and then the surname, which is Rambo. So it will print out John Rambo. Okay, so that is strings. Now let's look at another one there. Let's take the Boolean quickly. So that is the Boolean. Remember, Boolean values are either true or false. So let me just call this one value. So this variable is called value, and the type for the variable is Boolean, either true or false. So to this value, if I try to save a number now, you can see that it found an integer, but it wants a Boolean. Also a 10.9, for instance, now it's just a double, but it accepts a Boolean. If I add some text there, let's say the text of true, you can see it's still text, it's not Boolean. So for your Booleans to work, it must either be true or it must be the false value. So those are the only two values that you can have for the Boolean. It's either true or false. And then we'll have a look at Booleans a bit later on when we do the decision structures. But for now, let's just print it out. So if we print out, and you want to just print out that value, which will be whatever is saved in the variable called value, which will be false. So if we run it now and you print it out to the screen, the value should be false. Okay, let's look at the last variable for today, or type for today, and I'm going to look at the character quickly. So for the character, it's basically just a letter of the alphabet, and we can assign, let's say, a J there for the letter of the alphabet, and you can see that characters actually accepts characters as a single quotation mark. Characters are also number based, which means that I can add a number there, which is a representation of a specific character. So which means basically we can add integer values there for a character or normal character values. But if I try to do 12.9, it will say it's a double, it should be a character. Okay, so now for this one, let's just add, even if I add normal text as a double quotation mark, it won't accept it because it accepts only one character. So I'm going to use the J there, and that is the letter that we want to print out, and let's print out without double quotation marks just the letter of the alphabet there, and if we run it, you can see that we've printed out that letter of the alphabet. Right, so now we said this example will go about, or will be about, variables, literals, and constants. So what is a literal then? So we all know by now, hopefully, what is a variable. So these are variables, a place to store data of a specific data type. So now what is a literal? If I look at my variables, this would be a variable, but the value that I assign it, a number like this I'm doing now instead of a variable, we call this a literal. So literal is basically a notation for representing a fixed value in source code. For example, 20 will be fixed. Whereas first number, I can go and change first number if I want. I can say first number should now be 30. And then when we work out the average, it will be 20 plus 30, which is 50 divided by 2, and it should be 25. So there's the value of 25.0, which means that this is a variable. So for a variable, I can change the value of a variable, but a literal stays fixed. That 11 stays an 11. This 30 stays a 30. Let's go down a bit. So you'll also see that even in the system out print line, this text that I have there as raw code, raw text, will basically be my literal. The same for my name variable. That is the literal. This is the variable. That is the literal. This is the variable. For my Booleans, false is the literal there, and value will be the variable. The same for my letter or my character here. That is my literal. This is my variable. Now the last thing for this example will then be constants. Let's just have a quick look at what is a constant. So a constant are like variables in their declarations and the ability to look at the values stored inside of them. However, you cannot change the values while the program is running, and the value of a constant remains, rather unsurprisingly, constant. So in order to create a constant variable in Java, we will use the final keyword. So you'll see as soon as I add the final keyword to a declaration of a variable, I cannot change the value of that variable once it is assigned a specific value. So first number you can see is assigned the value of 11. Because I'm saying first number must now be a constant by adding the final keyword there, it means that this value for first number must stay 11 and I cannot change it throughout my coding. And that's why trying to change it then in this line will then give me an error and I cannot change it at all. So that's the difference between the final and the normal variable. Okay, so I need to remove that one line of coding then, and then everything would be fine. So the constant just means that this first number is now defined a specific value of 11, and I cannot change that value of 11 throughout my coding anymore. It must remain that specific value. Well, I can change it there. I can make it a 13, and then throughout your coding it must stay a 13. It just means that somewhere along the line I can't go and say first number equals something else now. It will give me an error. Now, another thing about constants is normally a good programming principle would be to make all uppercase when you're referring to a constant, which means that that first number there must actually be first, and you can use the underscore there, number. So all uppercase will tell us as programmers, somebody that reads your code, that that is in fact a constant because it's all uppercase. So you can see that I changed everything there. I know now, because it's final in Java, first number, that value cannot change, and it will stay the same throughout the coding. And that is it for this example. See you in the next video.